All right, so in this section, we're going to take a look at different reactions of aromatics. So remember back to our last section, we learned that aromatics are very stable, and thus they're generally unreactive. So we learned a whole bunch of reactions with alkenes, a lot of addition reactions. So for example, if we have an alkene, we simply add HBr to it. We'll get addition of the H and the Br across the double bond. If we try to do that same reaction with a benzene ring, we'll get no reaction, right? The benzene ring is not nearly as reactive as the double bond. But that doesn't mean that we can't do reactions with benzene rings. We actually can. We just need to switch it up a little bit. So if we have a benzene ring here, we can add things to it. So in this case, I'm just going to call this E+. Later on, we'll note that this is an electrophile. And if you just have a regular electrophile, it's not going to be reactive enough. Usually you need to add some kind of catalyst, or your electrophile needs to be activated in some other kind of way. And we can actually add our electrophile onto our benzene ring, right? So we can indeed do reactions with aromatics. A couple things to note here. Note that in this upper reaction, we had an alkene and then we added HBr to it, right? We added two components across this double bond. This is an addition reaction, right? We're adding two things to the double bond, and note that the pi bond is gone. Whereas in this aromatic system, we've actually just done a substitution reaction, right? We have this electrophile added, but it's taken the place of the H, right? It's a substitution reaction. So they are a bit different. And then note that our aromatic system is retained, right? We still have that benzene ring. We didn't delete out any pi bond. And finally, we're going to be drawing a lot of benzene rings. Note that I can also draw benzene rings like this, right? Hexagons, and then just a circle in the middle. That circle indicates that we have these alternating double bonds. So be familiar with either type of notation and know how many bonds and hydrogens each carbon has.